Find and simplify the difference quotient for f of x equals radical 2x plus 5. Now remember, the difference quotient is a specific mathematical expression, right? It's f of x plus h minus f of x all over h. Okay, so really we got to do three things here, right? We got to first find what f of x plus h is. We're going to subtract f of x from that and then divide everything by h. All right, let's do this on the side then, right? Well, we know what f of x is, right? This is radical 2x plus 5. But what is f of x plus h? Okay. So what we're going to do is we're just going to take the function and we're going to replace x with x plus h. So it's 2 times x. But once again, instead of putting the x here, we're going to put that x plus h and then plus 5. Okay, we can simplify that, I guess, right? We can distribute through the 2, so we get 2x plus 2h plus 5. Okay, so this is f of x plus h. So let's take a look at what we've done, right? We have f of x plus h, which is this guy, right? We got radical 2x plus 2h plus 5 minus f of x, which is radical 2x plus 5, and all of this over h. Okay? So you're probably looking at this and saying, right, what can I do? Well, I can't subtract these because these are not like terms, right? They look the same, but this one has that extra 2h in the middle. Okay, so how can we simplify this? Now, usually we rationalize the denominator, right? We don't want radicals in the denominator, so we rationalize. Okay, but in this case, wait a minute, there are no radicals in the denominator, but there are 2 radicals in the numerator. So in this case, what we actually do is we rationalize the numerator. Okay, so we're going to multiply by the conjugate of this guy. So we're going to multiply by radical 2x plus 2h plus 5. And instead of the minus here, it'll be by plus radical 2x plus 5. And we're going to do that to both the numerator and the denominator. So we get something that looks like this, right? So remember, we're rationalizing the numerator now, right? Not the denominator. Okay. Now let's take a look, right? So let's just put parentheses around these guys. And we'll multiply the numerator together. Now remember, whenever we multiply conjugates together, right? Essentially this is called the difference of 2 squares. So we know that when we FOIL, and we're going to get FOIL 4 terms here, right? But because these are conjugates, the outer and inner terms will cancel out. So really, what happens when we multiply these first 2 terms together? We just get 2x plus 2h plus 5. Now we know that the outer terms and the inner terms will cancel out. So notice what happens when we multiply the last 2 terms we get together. We get minus 2x plus 5. Okay. And on the denominator, we just get h times all of this. Now, there's really nothing else we can do, right? So h times radical 2x plus 2h plus 5 plus radical 2x plus 5. Okay. Now on the numerator, okay, notice that 2x cancels out with 2x, 5 cancels out with 5, right? And that should always happen. Okay, so whenever we do the difference quotient, okay, at this step, the original function, right, will always cancel out. What are we left with here? On the numerator, we are left with 2h. On the denominator, we still have this h times radical 2x plus 2h plus 5 plus radical 2x plus 5. But oh, wait a minute, notice what happens here, right? And this is always the second thing that occurs, right? The h will always cancel out. This h on the denominator will always cancel out with this h in the numerator. So we are left with our final answer. Our final answer is 2 all over radical 2x plus 2h plus 5 plus radical 2x plus 5. And it does look like a handful. Okay? This is the difference quotient. Okay? And remember, we cannot combine these, right? These are not the same terms. Okay, so we just leave this as it is.